Hi, my name is Blair Bridger. I'm a geomatics instructor at the College of the North Atlantic, located in St. John's, Newfoundland and Labrador, Canada. In today's lesson, I'm going to demonstrate how to reduce observed survey values of slope distance and zenith angle to mark, or what is commonly referred to as mark-to-mark reductions. This allows these values to be combined with other sets to determine averages. So let's look at our scenario. We have an instrument set up over point A and a target set up over point B. We have a measured instrument height HI and a measured target height HT. We have observed values of zenith angle Z and slope distance SD between A and B with respect to the instrument and target, but we need these values with respect to the ground points A and B. So how do we reduce these values? First, let's look at our observed quantities or values. We have a slope distance SD, a zenith angle Z, an instrument height HI, and a target height HT. We will use these values to first calculate the slope distance reduced to mark, or SDM in our scenario. This is a four-step process. Step 1, we need to find the horizontal distance between point A and point B. To find this value, we multiply our slope distance by the sine of our zenith angle, and this gives us a horizontal distance of 50 meters. Step 2, we need to find the height above the instrument at point A, or Y. To determine this value, we multiply our slope distance by the cosine of our zenith angle, and this gives us a Y value of 2.56 meters. This value can often be confusing, so we're going to take a closer look. Again, here's our scenario with a target over B and an instrument over A. If we draw a triangle over this, we can have a better understanding of what the Y value is. We have a height of an instrument above A, but we need this height above the instrument itself. And this is Y. So step 3 is to find the change in height between point A and B. To find this change in height, we use our height of our instrument plus the determined value of Y and subtract the height of the target. So this gives us a change in height between A and B of 2.79 meters. And this tells us that B is higher than A. In step 4, we find the slope distance reduced to mark. So to find our reduced slope distance, we use our determined values of horizontal distance and change in height and the distance formula. And we come up with a slope distance reduced mark of 50.078 meters. But we also want to find out what the zenith angle is reduced to mark, or the ZM value in our scenario. So to determine this reduced zenith angle, we have to use trigonometry and our determined values of horizontal distance and change in height. The reduced zenith angle is the inverse tan of our horizontal distance divided by our change in height. And this gives us a reduced zenith of 86 degrees, 48 minutes, 22.3 seconds. Now we have values that we can combine with other sets to determine averages. Thank you for attending my lesson. Does anybody have any questions?